I am Dr. Basir-Ahamed-Khan, Assistant Professor of Physics, Krishnath College. This is the third lecture of Module 11. The topic, the name of the topic of Module 11 is Behavior of Real Gas. In my previous lecture, that means lecture 1 and in lecture 2, I have discussed the deviation from ideal gas equation, Andrew's experiment on carbon dioxide gas, continuity of liquid and gases. In the second lecture, I have discussed what is vapor and what is gas, boil temperature, Van der Waals equation of state for real gas, and today I will discuss in my third lecture the values of critical constants, comparison with experimental curve, PV diagram, and defects on Van der Waals equation. Defects in the sense the deviation from the experimental result with the theoretical Van der Waals equation. Now, before going to discuss the values of critical constant, we know that the Van der Waals equation of state for real gas PV equal to P plus A by V square into V minus B equal to RT. This is Van der Waals equation of state for real gas. Now I want to discuss on Van der Waals equation. So if I expand this equation of state, then I will get P plus P V square plus A into V minus B equal to V square RT, or PVQ minus PBV square minus V square RT plus AV minus AB equal to 0, or just I arrange in this way: VQ minus B plus RT by P into V square plus A by P into V minus AB by P equal to 0. Suppose this is equation 1. Now from this equation we see that this is the third degree of V. This is an equation of third degree in V. So for a particular temperature there should be 3 values of V. From here, from this equation, we see that this is the equation of third degree in V. So we can say that for a particular temperature there should be 3 values of V for a particular pressure. Now if I plot this equation, then I will get, suppose this is figure 1, I will get the PV diagram like figure 1, because here if I plot this, then I will get for a particular temperature I will get the 3 values of V for a particular pressure. That means for a particular pressure I will get 3 values of V. That means for a particular pressure there are 3 volume, which is which deviates from our experimental result. So I plot here 4 isothermals T1, T2, T3 and T4. Obviously T4 is greater than T3, greater than T2, greater than T1. So this is the curve, this is the plot of equation of this equation 1. So if I plot equation 1, we get 3 values, 3 root of V for a particular temperature and particular pressure. Now from this isothermal, we see that there is no horizontal portion. There is no horizontal portion like the Andrews experiment. Andrews experimental curve is like that. This is Andrews experimental curve. Andrews experimental curve. This is Andrews experimental curve, and this is the van der Waals equations. Van der Waals equation. This is van der Waals equation, and this is Andrews experiment. Andrews experiment is like that. Here, then this horizontal portion, and here this is P and this is V. This is V and this is P. Here we get an horizontal portion, that means where the gas, by applying pressure, if I go through this, the volume decreases, pressure increases and volume decreases, and after this point volume gradually decrease but pressure same. That means the condensation, vapor, gas changes into vapor, and again applying the pressure, the vapor turns into the liquid. That means this is the horizontal portion. That means in this portion the gas turns into vapor and vapor turns into liquid. Here all this point, suppose this is A, this is B, this is C, this is D. At C point all vapor are turns into liquid, changes into liquid, and after that if I want to compress, compress, then volume slightly change with large pressure. By applying large pressure, volume is small change in the region CD. So in the experimental curve we get the horizontal portion, here we get the horizontal portion here. This is the horizontal portion. This is horizontal portion. But there is no horizontal portion in here, and that's why we get 3 values of V for a particular pressure. This is the van der Waals equation, but experimental value says, experimental result shows that there will be a horizontal portion below the critical temperature. Okay, so below the critical temperature each curve shows a maximum and a minimum. Here there is a maximum and minimum in the van der Waals equation of here we see the maxima and a minima. There is a maxima and a minima in the graph or in the curve in the van der Waals equation plot. So, however, at the critical temperature, the maximum and minimum point meets at a single point, which is the critical point of the gas. Here is the same. Here is the same as the Andrews experimental curve. Means at critical temperature or at the critical point, the both experimental curve, Andrews experimental curve and van der Waals equation are the same. But for below the but for the isothermal, which is below the critical temperature, there are maxima and a minima. There shows a maxima and minima on the isothermal. I see on the isothermal curve. So this is the comparison of experimental and the van der Waals theoretical equation of state, gaseous real gas equation of state. Now we want to calculate the critical constant of gas from van der Waals equation. The critical constants of a gas from van der Waals equation. Van der Waals equation. From van der Waals equation, we know that from van der Waals equation we know that P plus A by V square equal into V minus B equal to RT, and from here we write this equation in this way, that is this equation becomes VQ, I already shown in the previous page, VQ minus B plus RT by P V square plus A by PV minus AB by P equal to 0. So from this equation I write B plus RT by P into V square plus A by P V minus AB by P equal to 0. This is equation 2. Now this is a cubic equation of V. This is cubic equation. This is cubic equation of V. So for a constant temperature and pressure, V should have 3 values. Since this is a cubic equation of V, so from this equation we say that for a particular temperature and pressure we get 3 values of V. At critical point, the 3 values of V becomes identical. In our previous graph, we see that these three roots becomes equal at critical point. Becomes equal. These 3 roots of V become equal at the critical point. So we say, suppose at the critical point V equal to Vc, or V minus Vc equal to 0, or V have 3 root, V minus Vc whole to the power q equal to 0, or V cube minus 3v square into vc plus 3v vc square 3v vc square minus vc cube equal to 0. Suppose this is equation 3. This is equation 3. Now comparing the coefficient of these two equations, comparing the coefficient these two equations, this is 3vc here, this is 3v square vc square, and this is equal to this. Then comparing this coefficient of these two equations, we can write, comparing these two equations, we can write 3vc equal to b plus rtc by pc. 3vc equal to b plus rtc by pc. I write t by tc and p by pc because of the critical point. And next 3vc square equal to a by pc and vc cube equal to ab by pc. vc cube equal to ab by pc. So this is 4, this is 5, and this is 6. Now from equation 5 and 6, from equation 5 and 6, from this equation 5 and 6, we write 3vc square by vc cube equal to a by pc divided by ab by pc. That means I get 1 by b ab by pc into 1 by b, or vc equal to 3b. This is another equation. This is equation 7. Now putting equation 7 in equation 6, putting 7 in 6, we get 3b whole cube equal to ab by pc. From here we get pc equal to a by 27 b square. This is the value of critical pressure Vpc. Now putting 7, this is 8, putting 7, 8 in 4, that means we get Tc equal to 3, putting 8, 7 into 4 we get 3 into 3b equal to B plus RTC by PC. PC means A by 27 B square. A by 27 B square. A by 27 B square. That means from here we get TC equal to TC equal to 8A by 27 RB. 27 RB. This is the value of TC. That means equation 7, 8 and equation 9 gives the value of critical volume, critical pressure and critical temperature. Now these are the values of critical volume, critical pressure and critical temperature. Now the last topic is the defects on van der Waals equation. The defects on van der Waals equation. Defects on van der Waals equation. Van der Waals equation. Van der Waals equation. The first point is that van der Waals equation shows a maxima and a minima in an isothermal below the critical temperature. That means first point is that there is a maxima and minima. There is a maxima and a minima in van der Waals isothermal curve. But in Andrews experiment curves, there is no such maxima or minima. So van der Waals equation shows van der Waals equation shows a maxima and a minima. A maxima and a minima. Maxima and a minima. Maxima and a minima. Maxima and minima in an isothermal below critical temperature. Below critical temperature. Below critical temperature. Critical temperature. Below critical temperature. Below critical temperature. But in Andrews experiment curves, there is no such maxima or minima. But in Andrews experimental curve, Andrews experimental curves, Andrews experimental curves, there is no such maxima and minima. There is no such maxima or minima. Maxima or minima. Maxima or minima. This is the first point. Next point is that the constant A or B, van der Waals constant, the constants A and B in van der Waals equation are found to change with substance. and also with temperature. The next point is that the constant A and B in van der Waals equation are found in van der Waals equation, van der Waals equation, van der Waals equation are found to change with substance and also with temperature. To change with substance and also with temperature, that means A and B, the two constants in van der Waals real gas equation, there are not fixed constant. There is no fixed constant. They also the function of temperature dependent. That means with the temperature and with the substance, the constants A and B are also change. Third is according to van der Waals equation, Vc equal to 3V, that means B equal to 1/3 Vc. But experiment shows that B almost equal to half Vc. This is another defects of van der Waals equation. Next, this is 4. According to van der Waals gas equation, RTC, that means the ratio RTC by PCVC. TC means critical temperature, PC means critical pressure, and VC is the critical volume. This gives the value 1.67. But it is found that experimentally shows that this value RTC by PCVC equal to 3.75. This is another defect. And next, the actual boil temperature differs from the value deduced from the van der Waals equation. The actual boil temperature, now we know that the boil temperature TB equal to A by RB, which is now from van der Waals equation. So the another defect is the actual boil temperature differs from the value. This value means the value of boil temperature differs from the value differs from experimental value. That means the experimental value of boil temperature is not the same which is coming from the which is deducing from the van der Waals equation of state. Okay.